This conference will now be recorded.
All right, so now we'll get started with this and let's see. Before we move forward with Kubernetes out here, let's try to do a quick revision and then let's try to address or let's try to, let's say, answer a couple of questions and then move forward out here, guys. Now, for this, I will need your help to help me explain what you know really about Kubernetes so that we can move forward out here as such. So, very importantly, let's identify a couple of terminologies. Do we know what is a pod in Kubernetes, guys? Yes, no, maybe. What do we mean
Yes,
by something called pod? Yes, and what is a pod exactly, Madhu?
pod is nothing. It is just an object in the Kubernetes.
Mm-hmm.
By using the pod only, we can run the container on top of the pod.
And the container on top of the pod.
By
Very good.
use,
Yes. So pod is the smallest deliverable unit in a Kubernetes cluster. By using a pod using a pod, we can go ahead and run a container inside this particular pod. We can run a container inside this particular pod, and this pod runs on something called as a node. Node is nothing but a backend running virtual machine. The smallest deliverable unit is called pod, and a pod has a container running inside it. And how can you connect, or how can you rather create a pod? Did we try creating a pod? And if yes, what are the different ways to create a pod, guys? What are all the ways that we see to create a pod here?
mm, but
Go ahead,
We
please.
gave
I mean,
command.
yes, we gave a command, and what was that command, Priyanka, if you remember?
Yes, kubectl, kubectl, then run space run,
kubectl, yes, space run, and the name of the pod, and
name of
hyphen
the pod,
hyphen name
image.
of pod, and then hyphen hyphen image is equal to something,
Yes.
is equal to what is exactly the image out here as such. So let's do that real quick, and let's also try the other way around using the YAML file, and let's quickly recap the replica set and then go into deployment. That will make more sense so that everyone is on the same page and no one is left behind. So again, I have a Kubernetes cluster that I created, and let me connect to this particular cluster. In order to connect this particular cluster, I go into my PowerShell, and in my PowerShell, kubectl commands are already installed. I go ahead and firstly I set my subscription details. I said, okay, fine, I tell Kubernetes that what, I want to go ahead and let's say set my context out here. And second command, I say, okay, fine, AZAK is get credentials hyphen resource group name. So I just go ahead and run this out. And this is where I'm trying to, let's say, pull, let's say, the credentials of my Kubernetes out here as such and store my Kubernetes. And once this is done, I start by doing a very small inquiry telling kubectl get pods. So I try to see what are all the pods that are actually running in the background. And now it says there are no pods running in the background as such. So this is where I start creating something called kubectl run the name of the pod. I'll say first pod hyphen hyphen image is equal to, I'll just give the source of the image out here as such. So I'll say it is Nginx latest, and I don't need to, let's say, give the bracket out here. That's good enough. And once I give it an enter, this is now going to go ahead and create a pod for me. Now it's telling this is first pod. And if I go ahead, say kubectl get pods hyphen o wide, an output wide, this is going to give me the private IP address of the node on which the pod is running, the name of the node on which the pod is running, and etc. And if I want to go ahead and let's say do much more, let's say, inspection out here, I'll say kubectl describe pod. / the name of the pod. It says first pod, and as and when I do an enter, now this is going to give me much more understanding of what kind of pod was created, when was the pod created, what is the IP address of this particular pod out here, and what is the image source of the pod. A lot of information out here as such. Again, if I want to expose this pod over the internet, not running the command, but if I just go into the command out here, again, all the basic commands out here that I'm, let's say, trying to go into, I would do a kubectl expose the pod over something called as a load balancer, and this will go ahead and give me the public IP address, and I'll go ahead and, let's say, access the pod over the public IP address out here. So one of the methods in which I can go ahead and, let's say, create a pod. Now delete a pod, I'll say kubectl delete pod and the name of the pod out here. I'll say first pod, and it's saying the first pod got deleted. And now if I run my command once again, telling kubectl get pods, this is gonna just give me in return telling that, you know what, there are no pods actually running on your Kubernetes cluster. The reason being I've deleted everything out here as such. Now this is one way of creating my Kubernetes pods and also the Kubernetes service. How is that? Is run pod and then go ahead and, let's say, expose this particular pod over, let's say, Kubernetes, let's say, service out here as such. But the other way, which is the most preferable way in order to, let's say, create a Kubernetes pod, is by using a YAML file. Now this is where, as someone asked me, is that I'm a little confused in creating this particular YAML file. How do I really approach this out? You know, what is, let's say, the easier way to process out here as such? Let's look at that. So for the very first thing, see, you'll have to understand the basics of YAML. You'll need to understand how YAML at a primary level really works out here as such. So I'll say YAML Kubernetes. This name. Let's select this particular folder. I'll say don't save. And this is an empty folder in which, let's say, I'm opening. It is an empty folder out here, inside which I'll say basic.yaml or basic.ym. Sorry, basic.yml out here. Let's rename this particular file a basic.yml file out here, wherein I'm telling that if you want to go ahead and start creating a Kubernetes, let's say, file out here, now it has to contain 4 different top level objects: API version, the kind, metadata, and the specification. 4 top level objects out here as such. The very 4 basic objects out here. And in here, I am creating, let's say, a pod. So I'll say v1, version 1. I'll say kind. I'll say it's a pod. In the metadata, I am giving the properties of the metadata. So I am doing a tab under metadata coming here. I'm giving some key value pairs telling the name of the pod is my first pod. Then I'll give much more information like labels, wherein these are key value pairs. I'll say type is equal to front end, something like this. And inside the specification is where I would go ahead and, let's say, start writing containers. And I would say that the name of the container is my first container, and the source of the image that I want for this particular container would be an Nginx latest. This is how I'm writing. So what I did is that I started with the 4 top level objects that I want. I then went ahead and I said, okay, fine, this is what I need out here. I'll save this out. In order to now run this particular file, or in order to, let's say, deploy this particular file, all I'll do is that firstly go into the directory of the file. So directory where the file is actually, let's say, really running out here. So I'll say copy path, cd into this particular directory. So I'm doing a simple cd, a change directory out here. And if I say ls, I have a basic.yml file, and the basic, I mean, this is, let's say, pod.yml file. This is something I will rename this back to, not a problem. And in order to, let's say, deploy this out, I'll say kubectl apply -f, and I'm just going in and running this out. So what I did is that I'm saying apply -f inside this particular same directory, or you can give the entire file path. And this is now going to create a pod for you. I say kubectl get pods. I have my first pod, 1 out of 1 running restart 0 ages 12 seconds. So I just created it 12 seconds ago, and the pod is now running. Now the question here that let's say earlier Jayanti had was that, you know what, I'm a little confused when I write this particular YAML file. You know, I do not know what to write first, or something goes error, something goes wrong. How do I correct this particular error? Now, one of the easiest way not to write this out is either you know the structure or you know what are the plugins to use. That's where I'm telling that you can go into, let's say, VS Code, say Kubernetes, just say Kubernetes extensions out there, and you have something called as Kubernetes templates. This is one of the extension. I'm not sure if we spoke about this. I'm pretty sure if we covered pods and all these things, we spoke about this already. There's an extension out there called Kubernetes templates. Please download this out. Now let's see. Once I download this, let's say I create a second pod. Let's say second pod.yml. I want to now create a second pod. I don't know what is the syntax. I don't know what are the top level objects, nothing. But I know that I want to create a pods for Kubernetes. So Kubernetes is also called as K8s. So I'll say K8s and I need a pod. As and when I do this, as and when I say enter, I get the entire definition out here right now. Again, the top 4 level objects: API version, kind, metadata, and specs. So I'll say API version is good, nothing to change here. Kind is also good, nothing to change here. Metadata, I'll say my second pod. Namespace, I don't need to really mention this out, so I'll remove this out, or I can comment this out here. I do not really need this, I can comment this out. I'll say type here is a front-end application. This is my metadata, I complete this out. Once it's done, I'm coming to the specifications. Inside the specifications, I have, let's say, a couple of things like volumes, restart policy, and all these things out. Let's go into containers, into the names. So it's telling image, the image source. I'll say it is Nginx latest. Then there are some resource limits. And under this, there are some environment variables that they've passed. I don't need this at all. I can remove this happily. I don't need this. I remove that happily. I have some ports. I don't even need to mention my ports. I'll remove this too. I don't need the volume mounts. I'll remove this too. I don't need this volumes. There's an entire section that tells volumes. I'll remove this too. Neither I need the restart policy. I'll remove this as well. That's it. Now this is my definition, or this is just telling what are the resource limits out here, guys. If you don't want this, you can also remove this out. I mean, I'm super happy to remove this out, but if you just remove this out, right, it's just going to give you some warning messages telling that there are no resource limits, let's say mentioned out here and so on and so forth. But it's super fine. If you want to keep it, you can keep it. If you don't want to keep it, don't keep it. Not a problem. Here, I'll just say this is my second container name. So I'm just fixing all those things out. And then I go ahead and run the same command. But this time around, I'll go ahead, let's say apply a different file. I'll say this is basic.yml and I have some file called as secondpod.yml, and I'll apply this out here. So that's it. All I'm doing is using a template, loading my entire definition out there, and then going ahead and telling, okay, fine, you know what, I need a pod. I need, let's say, a pod out here. I deployed a pod out here as such. And as and when this is done, now if I say kubectl get pods, I have a first pod, I have a second pod. Both are running right now. Both are created from a YAML file out here as such. Does that answer your question, Jayanti? Was this something that you were looking at, on that you had a difficulty in writing the YAML file for Kubernetes? And does this help you out?
Yes, yes. So that template I can, like, if I want to create any other pods also, I can, like, take a use of that, right?
Anything like, any pod, replica set, deployment definition, secrets, config maps, whatever that you want to create in Kubernetes, you can just call that particular template, start creating it out.
Okay. Thank you, Abhishek.
Yes, any more questions still here, guys? And are we clear on what are pods? How do we create them? So I'm just trying to recap this out. That's the reason I'm not going to the depth of it. I'm just trying to recap this on a very high level overview so that this will form that basics for our let's say Kubernetes deployments out here. That's the end goal that I want to really achieve out here as such. Now, now this is the question that I have for everyone, guys. Is that we are able to create pods. We created a first pod, we created a second pod, so on and so forth. Now, what is then the use of a replica set? Why are we even going for a replica set out here? Now, this is something that we covered already, but I just want to make sure that we are all staying in the same page before I go into the actual concepts that we have right now. So, can anyone please summarize on why do we need a replica set? How is it better than a pod? Did we cover that, guys? Did we cover that initial question on why are we going for a replica set?
If you by using replica set, we can reduce the downtime of application by making
Okay,
more pods using the replica
by
sets.
making more pods. But I can also go ahead run my Kubernetes supply command again and again and make more pods, right? I can multiply the amount of pods like that. Then how does a replica set really help me in making sure that my application doesn't have a downtime?
Once we replica set automatically by itself creates pods once we delete it
By
or some.
itself creates the pods. Exactly. Replica sets automatically create pods when the pod is being deleted. When you
Without
normally
human
create a,
intervention.
yes, without human intervention, as in
It's
when your pod is getting down, a new pod is created or a new pod is replaced over there. And this makes sure that you at least have one pod that is listening to a user request and your application is not going down. Which means, first let's do one thing. Let me go ahead and delete the pods out here. So let me go directly into the Kubernetes, let's say, into the Azure portal and say workloads. Created two pods out here right now. I'll just go ahead delete these two pods out here right now. So I'll say this is the default namespace. There is this first pod, there's the second pod. Let me delete them out. And while they're getting deleted, let us go ahead write replica sets. Again, top 4 level objects are always going to be there. You have your, let's say, API version. You have your kind. You have the metadata. You have the specification. And inside the specification, you are again going to get something called template. So to make sure that is super easier, I'll say K8's replica set. All I'm doing is calling something called K8's replica set again to make sure that I have all these top level objects. Yes, I have a four top level objects. One, API version. Two, replica set. Three, metadata. And in metadata, I'll just tell that, okay, fine, metadata. This is my first replica set. In the name and in the labels, I'll say type is equal to front end. So this is my metadata. I'll collapse this out. I'll open my specifications. Let's see. The very first thing it's telling, okay, fine, the amount of replicas that I need. I'll say 6 replicas. I'll come down to the selector. This is something that we'll cover in the last. We'll understand why selector is coming in the last out here. So I'll get it to the last out there. I don't need this right now. I don't really need this right now as such. Rather, I will put it at the end so that we can cover all these things at the end out here. So I just pasted it. I'm just pasting it out here because I don't have any errors out there. So let's look at the template. Let's forget about the selector for now. Let's look at the template. And here inside the template, it's saying metadata. I'll again say type is equal to front end. And then I have the specifications. So if you look at this, right, this is the same thing what we have written here. Metadata, specifications, and all these things. So all it did is that just copied and pasted it out inside the template section. Now it's telling container. I'll say something like test container. Image, I'll say that this is an Nginx latest image. Then I'll go ahead and say that this is let's say I don't need the ports, I don't need the environment variables, I don't need the volume mounts, nothing. I don't need all these things out. All I'll change is that I'll say, okay, fine, you know what? Now the selector here is not app is equal to, let's say, my app, but its type is equal to front end, meaning whatever pods that you see running with this particular label, go ahead and add them into the replica set so that replica set can manage all these things out. And my replica set definition is done. I just started with K8s and I said, okay, fine, you know what? I need a replica set out here. That's it. I got my replica set out here as such. Now, if I want to create a replica set, okay, that's a wrong command. Should throw me an error. Will throw me an error. I'll say kubectl apply -f and I look for my replica set definition.yaml and I'll say enter. As when I do this, this is now going to create a replica set for me, which means that if I say kubectl get rs replica set, this is now going to tell me that yes, you have a replica set with about 6 pods that are running. These are desired. These are running inside it. And if I now say kubectl get pods, there are going to be 6 pods that are running in the background, which were created by my replica set and now being managed by my replica set. And if I now want to expose all these pods over a load balancing service, all I'll do is that I'll say this is service.yml YAML. Now for the service file, I would just go ahead into the our documentation, right? Just go here. This is the basic service file. Just get this out. Service.yaml. I'll say this is load balancer. I'll say selector here is type is equal to front end. Rather very simple definition. You can use that particular service.yaml file again and again that is there inside our let's say repository. That will serve as one master file that you can reuse it again and again out here. And I'm telling that load balancer that you know what, please go ahead, check out whatever pods. Let me refresh this out. Whatever pods, whichever pod has a name label of type is equal to front end, take that particular, let's say, pod, add it inside your load balancing backend. That's it. This is what I'm now telling. And in order to create this out, I'll simply go ahead. I'll say apply -f service.yml. Please go ahead, create a service out here called as a load balancer. And if I say kubectl get svc service, not svx, sorry, svc service, it's telling you know what, you have a load balancing service with a public IP of something called 2096.144.149. I'll just copy this out, go into my Google browser, is this in here, and this is now trying to load one of the available pods that is running in the background. In case one pod goes down, let's say I delete this out. My replica set is intelligent enough to automatically go ahead and recreate something out here as such. So if you look at my replica set out here, 1, 2, 3, 4, 5, 6, still 6. This one got created 15 seconds ago, and this replica set will always and always make sure to have a configuration existing in place. This replica set is always and always going to make sure that you have a configuration existing in place out here as such. and it will make sure that whenever you go ahead and let's say give 6 replicas or 7 replicas, you auto scale it automatically. The auto scales and let's say the scale ins, meaning both the scale outs and the scale in, they are rolled out incrementally, meaning a replica set won't go ahead and say, okay, fine, I'll delete all the 3 pods at once. If you want to scale it down, it'll say, I'll delete 1 pod, second, I'll go for a second pod, third, I'll go for a third pod, I'll delete it in an incremental way so that your application doesn't undergo a downtime. That is where a replica set as a concept comes into picture. Now, then, finally, or before I go there, any questions with the replica set on what do I mean by something called as a replica set out here as such? Any questions with this that I can address, that I can take, or is not clear till here before I go down or before I come down with something known as a deployment out here as such? Anyone? Any questions?
No, no.
All right, great. So then, if replica set is so good, then the question is, why are we talking about something called as a Kubernetes deployment, which is now the ultimate object out here? What exactly does a Kubernetes deployment do? How is it better than something called as a replica set out here as such? Let's see this. Let's say that I am a DevOps engineer. I joined very recently in this organization, and my organization is telling me that, you know what, please go ahead and the need of the organization today is to upgrade the image that a replica set is actually running within a container. I don't need Nginx latest. Rather, I need an image called Nginx version 1, something like that. So this particular, let's say, command was given to me by one of my seniors. And what I did is that I said, okay, fine, you know what, this is simple. I'll go into the replica set file. And what I did is that instead of putting version v1, I said va1, something like this. By mistake, I put some different version out here that doesn't really exist anywhere, meaning this image or this Docker image that we are talking about doesn't exist anywhere. Nowhere this particular image exists. And what we are trying to do is that we are trying to deploy an image that doesn't exist anywhere on an existing running replica set, which is already being used by my live users. This is something that we're trying to do. So let's see. Interestingly, let's see what happens when we do this. So again, I'll say kubectl apply -f replica set. As in when I do that, it's telling replica set has been configured. And now if I go back into my replica set, kubectl is simply going to listen to my words, telling that, okay, fine, you as a user asked me to configure a replica set. I configured a replica set for you. And now it's telling, okay, fine, there are about 6 pods. 6 are ready. That's good enough. And if I go inside a pod, it's telling everything is running right now. All is looking good. Let me go and refresh my page. Still getting Nginx. Let's see what did I do out here. VA1, this is good enough, and this reconfigured out here as such. Let's look into my pods, and let's look into one of the pods that is running. Let's check this out. It's still running Nginx latest. Okay, let's do one thing. This is -f .yml. This is good enough, and I changed the name of the image out here as such. Let me put some random image out here. Which probably doesn't exist. And I'm trying to reconfigure this out. Selecting Nginx latest, not accepting my command. Okay, it'll take some time to update this out. Let's go to workloads. Let's try to maintain the replica set out here. Let's look at that. Okay, and if you look at this, it's telling this is now a random image out here. And let's look at a pod. It's still taking Nginx latest out here. And if you check this out and to the events of this particular pod, saying this is pulled, and all that stuff. So the image is not even going inside. Fine. So if you look at this, my replica set is now running an image called random image that probably doesn't exist on the Docker Hub repository at all. Maybe I, as a DevOps engineer, I have made a mistake that someone gave me some image to be added, and by mistake, this is a completely human error. By mistake, I, as a DevOps engineer, I went ahead, let's say, put some image out here, updated this out, done. Once you do this, observe this after a couple of minutes, your application will stop working because your image pool, right, or the image what your pod is actually referring to, or the image what your replica set is actually referring to, this is not in a right state, or rather this image is not at all there. So as and when the replica set, or as and when, let's say, your pods get updated with this particular random image, Kubernetes will simply fail, telling that, you know what, I don't know where this image exists. And what happens here is, since you're updating the entire replica set, all the 6 pods that are right now running will start taking those images. All the 6 pods that which are actually running in the background will start pulling this particular image called as a random image, because you have given a command telling that please go and pull a random image here, right? So I'll tell, okay, fine, yes, you asked me for a random image, so it'll start updating all those 6 pod definitions out here as such. So it doesn't really know whether this particular image exists or not, and it's trying to pull all these things out, and this will cause an application downtime. So one way of looking at application downtime is that, let's say, some pod crashes out here because of, let's say, the node unavailability or something like that. Replica set will take care of it. But this is a human error, and in order to avoid all these human errors, is why we recommend doing something called as a deployment. Like a replica set, we have something called as a deployment object in Kubernetes. How is it really going to help you out here? This is going to help you out in doing rollbacks and updates with zero downtime and in a safer way. What do I really mean by this? What do we really mean by doing a rollback? What do I really mean by doing an update? What exactly do we mean by this, and how exactly would a deployment definition help you here? What exactly would a deployment definition really do here, and how would it really help you out here? Let's look at that particular question. Let's answer that particular question. And how is it safer than a replica set? How will it protect your application is what I'm really looking at. So what I'll do firstly is I'll delete the replica set entirely. So let's go ahead and delete this out. Let's also go ahead and delete the service, and let's try to create a Kubernetes deployment object out here. So let's go into the services, and I'll also delete my load balancing service, which is nothing but my load balancer, and I'll delete this out as well. So I'll say please go ahead and delete this one, and I'll recreate these services. Not to worry, I will go ahead recreate all these services out here by using a deployment definition in Kubernetes. And when I say a deployment definition in Kubernetes, let's see what I need to do out here. Again, this is the basic skeleton for a pod. Then we define what is a replica set. Forget about second pod because this is an example. Then we had a service. All I'll do is I'll now say deployment.yml. YAML. I'm creating something called as a deployment definition. Either you can say kats and then say deployment and say enter, or I already know how to create a replica set. By now I already know how to create a replica set. I'll just copy this out, paste it here. I will just rename this, the kind here, to deployments. Deployment out here. That's it. All I'm doing is I'm now renaming this entire kind into something called as a deployment. And as when I do that, then it's telling there is no DNS label. Each pod should contain resource limits and a couple of, let's say, warnings out here. All that changes between a replica set and a deployment definition is the kind. That's it. So if you even load KH deployment, same thing. Metadata, the specifications, and inside the metadata, inside this particular metadata out here, I'll say this is my first deployment. And I don't want this namespace, so I'll comment this namespace out. Labels out here, I'll say this type. I'll say this is again front end. And once this type is declared here, let me do one thing here. Once this type is declared here, again, selectors, I'll come down to this in a second. I'll address firstly the remaining template out here. I'll say this is something like 6 replicas out here that I want. I don't need a strategy and all these things, so I can remove this out. I'll say template here. The labels here, I'll say the type is equal to front end. And in here, the containers and all these are, let's say, the comments out here, so you can ignore them safely. I'll say containers, I'll say these are Nginx containers. I'll say the image here is Nginx latest. Resource limits, live probes, all these things, I don't need this at all. The live probes, ports, volumes, restart policy, everything till here, you can safely ignore. These are just a resource limit, so you can keep it the way it is. Come back into your selector. So come back into your selector. All I want to do is I just want to change the selector. Type is equal to front end. So whatever I did for my replica set, I'm doing the same thing for my deployment definition. The only thing that is now changing is the kind. Whatever is the name or whatever are the values of your replica set, you can simply take that. If you're not comfortable putting the selector here, you can remove this out here, place it in here. The alignment misses slightly out here as such. Place it in here, should be good enough. And I'm now telling that I need 6 replicas out here right now. So it's nothing but just changing one simple value out of the pod, renaming that guy to, let's say, something like deployment. And I'll now go ahead and start applying this out. So what really happens with this? Let's look at this again. I deleted my deployments, I deleted my replica set, I deleted all those things out, right? So if I just go here and I'll say kubectl get pods, don't have any pods. As a kubectl get replica set rs, don't have any replica set. kubectl get svc service. I just have one default Kubernetes service. I don't have my load balancer, nothing. So I have nothing out here. I'll just save this out, come back. The kubectl apply -f. Same thing. And I'll say deployment.yml. Instead of telling replicaset.yml, I'm now telling this deployment.yml, saying enter. And as when I do an enter, now this is going to create something called as a deployment. What does that have exactly? Let's see. The kubectl, let's say, let's do one thing. I'll recreate the deployment, but let me delete this out once again and recreate it out. This time when I create this out, I will add one more thing out here. Let me delete this out and recreate it once again. The reason that I'm deleting this out and recreating is because I want to save the history of my deployments. So if I'm going ahead, let's say with creating the deployments and all these things out, I want to, let's say, go ahead and record all my steps that I'm using. So allow me a quick minute in order to delete this out. And once this deleted out, I'll say apply hyphen hyphen record. So what I'm doing is that whenever I'm doing an application, whenever I'm doing, let's say, a rollout, meaning whenever I'm updating it out, I'm recording what my status is. And if I say kubectl rollout history, and okay, you say kubectl rollout history, deployment, my first deployment, and let's say kubectl get deployment, and I have something called as deployment that got created right now. And not only this, if I say kubectl get rs replica set, it's already created a replica set as a part of my deployment. So replica set is now coming as a part of my deployment. And then if I look at kubectl get pods, then it is telling yes, you have around 6 pods that are running, and these 6 pods, they are now created as a part of your deployment. Again, I have mentioned all these commands here as well. Same commands on how do I, let's say, go ahead and give you a deployment and all these things out here as such. So I'm going ahead and I'm just telling, okay, fine, this is my first deployment. This is, let's say, the name of the deployment and all that stuff out here. This is now created a couple of objects. What it has created is this. Yes, it has created something called my first deployment. Yes, agreed. Inside that particular deployment, it's internally created a replica set, and inside that replica set, it went ahead and it created something called as pods out here as such. So it has all the 6 pods out here as such out there. Now, if I want to do any changes, let's say I don't want this to be 6, I want this to be 3. And what I want to do is that I'll just go ahead, I'll rerun my command, telling kubectl apply deployment, apply hyphen f deployment.yml hyphen hyphen record. And as and when I do this, this is now going to tell, okay, fine, I've configured it out. But now see guys, just look at this. If I say kubectl describe deployment / my first deployment, what this is now going to do, or what this would have going to do right now is this. Earlier, I have a replica set with 6 different pods out here. Now, if you look at my, let's say, deployment object right now, and look at the replica sets right now, it earlier had 6 different objects. Later, it is now going ahead and doing just 3 odd objects out here. But again, if you look at this, it did not scale down altogether. It did an incremental scale down. What do I mean by that is that it's trying to pull each and every object out here, meaning it's trying to go ahead and say, okay, fine, you know what? Let me not go ahead and let's say pull everything at a go. I'll not do that. Let me go ahead and pull one pod firstly, see whether my application is working, pull second pod, pull third pod. You probably might not be able to see this here, but in the background, it's trying to go ahead and let's say incrementally roll out all those things. Now let's see that tomorrow my client is coming to me and telling that, okay, fine, you know what? I do not want to use Nginx latest. Let's say docker hub.com docs.docker, or let's say hub.docker.com. And if I go into the Docker documentation, I'll say explore, I'll say Nginx. And as of now, I'm using an Nginx latest image. Now, let's say I don't want to use an Nginx latest. I rather want to use something like an Nginx Perl. This is the version of the image that I have. My client is telling me that, you know what, Kiran, that I don't want to use Nginx latest. Rather, I want something like an Nginx Perl. let's see Nginx Pearl, which is an earlier version. Can you go and use this? And say, of course, yes, I'll use this out. Big deal. I'll go ahead, change into my file, and I'll say, you know what, this is not Nginx latest. This is Nginx Pearl out here as such. And this is what the deployment has to do right now. As and when I reapply this particular deployment, all the 3 pods that are running inside this particular deployment right now, which are pod 1, pod 2, and pod 3, and also the naming convention of the pod follows, let's say, whichever deployment is a part of, it follows that particular deployment and also a unique ID out here. And it's now telling that, okay, fine, all these pods right now, each and every pod, if I go into it, these 3 pods, look at the IDs. It's saying my deployment 568, something like that. And then you have 568 C, something like this. This is the ID of the replica set. So it's adding the ID of the replica set plus something else out here. So, and if you look at this, there's only one replica set with 3 different, let's say, objects out here. And the entire replica set is now running with, let's say, Nginx latest. Now, the duty of your deployment, or the task for your deployment, is to change this replica set to run an image called Nginx Pearl. So it's trying to, let's say, go ahead and run an image called Nginx Pearl out here, which means that all the 3 pods that are running inside this particular replica set, they need to upgrade themselves to Nginx Pearl. Nginx Pearl, Nginx Pearl. All these 3 needs to upgrade in Nginx Pearl and so on and so forth, but in an incremental manner, because this is now a live running environment. This is now a live running application right now. I don't want a user to face any issues out here. So what I can do is I can safely go ahead, rerun my deployment once again by using the command called apply-f deployment .yml record. It's telling yes, it's been configured. Now check this out. Let's describe the deployment once again and check this out. This is what happened. Look at the history of your entire deployment out here right now. Initially, this deployment created a replica set with a name called 569 something and added 6 different pods out here. Later, I did a scale down. So it said, okay, fine, you know what, I'll remove 3 pods here. I'll give you 3 pods. Good enough, not a problem. But now, when I am doing an update, check this out. There is a new replica set it created. It says, okay, fine, you know what, there is a new replica set that is coming into the picture, which is 788DD9896 with 1 pod here. And this pod will contain the new image called Nginx Pearl. Not the Nginx latest, but I still have the old pod, or I still have the old replica set with 2 pods out here. 1 pod was deleted from that particular replica set. It's telling, okay, fine, the old replica set, which is running on Nginx latest, let me delete 1 from there. I won't delete all the 3. It's telling, okay, fine, now there are 2 pods running Nginx latest. 1 pod which is running Nginx Pearl. Is my application working? It says yes, it's working. So it'll tell, okay, fine, you know what? Let me then get this number slightly different. Let me add 1 more pod here, minus 1 more pod here, meaning that's the reason. If you see this, the new replica set is having 2 pods. Old replica set is reduced to 1 pod. Finally, it's telling, okay, fine, new replica set is now coming down to something called as 3 different pods out here right now. So now if you see, just refresh this particular page. And now in the replica sets, I have 2 different replica sets right now. If you see this, it's still saving the last replica set, the last known good replica set out here. The new replica set contains something called Nginx Perl. It's saying yes, there is a new replica set on the block which contains Nginx Perl out here, and there is the old replica set with Nginx latest with 0 pods, nothing there. But it did not pull all your pods at a go. It did it in an incremental manner, in a phased manner. These are called rolling updates. Kubernetes is known for loading updates. Kubernetes is known for zero downtime deployment updates out here. Meaning I don't have any downtime out here. Neither I have any issues while rolling out that particular update because my application doesn't crash. Also, in case your client feels that, okay, fine, you know what, no, Kiran, we don't want to do Nginx Perl, we want to get it back to Nginx latest. What Kubernetes does is Kubernetes, if you run this particular command called Kubernetes rollout history and say, please give me the history of deployment with the name called my first deployment. Now, this is the name that I given. As and when I do that, it's now going to tell me that, okay, fine, what are all the history that I really did, or what are all the things that I actually did till now? No, what exactly did I do, and so on and so forth. It's recording all those commands out here for you. It's recording whatever it was done out here. Now, if I want to undo my updates, meaning if I want to roll back, meaning if I want to go back to my Nginx latest, all I'll do is I'll say Kubernetes rollout undo and give the name of the deployment, telling it is deployment / my first deployment out here. What I'm doing is that, fine, the name is something that I give differently. So I'm trying to do a rollout. So what it's doing is saying, okay, fine, you know what, I'm trying to do a rollback. And if you look at this, just observe this out here on my screen and see this out. Check this out. It's now telling, okay, fine, now I'll again pull back the Nginx latest, incrementally add the pods, and also remove safely the pods that are already there out here, which is Nginx Perl. It's telling, okay, fine, Nginx Perl was the older one. I mean, it's now pulling the Nginx Perl, telling that this is the older one. Then it's now going ahead and doing a rollout undo out here. So it's undoing all the, or it's, let's say, going ahead, undoing all the changes that I have done. And now it's telling, okay, fine, let me get it back to, let's say, the latest. And this is also an incremental update, or an incremental rollback, rather, I would say. So check this out. Again, if you see this, this is now going in and telling, okay, fine, you know what, this is how my replication controller did work. So it's telling, okay, fine, I'll increase the controller to, let's say, again, it's telling combine from the similar events, scale down the replica set to 0, and increase the other replica set, which is a newer replica set, to 3 out here as such. So all your rollouts and all the updates are going to happen in a phased manner. Also, looking at a similar situation earlier, let's say that some random person went ahead, updated this file. And what I did is that I updated my image out here to something that doesn't even exist at all. Let's say I, as a DevOps engineer, by mistake, I went and updated something out here. I don't even know whether it exists or not in the doc, in, let's say, the doc hub. I didn't know that. I just updated this. And now I'll go ahead, try to roll this out once again. So I'll say kubectl apply -f record. And I'm trying to, let's say, update this out, and let's see what happens now. Kubernetes is now intelligent enough. It's now telling, yes, I'll take your command, great, but let's see if the pod is actually working with the new image or not. And actually, if you see this, one of the pods failed, but you still have 3 different pods. What Kubernetes did is that Kubernetes is smart enough. Kubernetes is telling, you know what, I'll create a new replica set for you. The older replica set which was actually working, this is not destroyed. The pods will still work. The pods will be still there with Nginx latest. But you asked me for a new replica set, or you asked me for a new deployment definition with something called Nginx Perl 1.7, something like this. And if I go inside my Kubernetes pod out here and look at the events out here as such, It's telling successfully created the pod. This is good enough. But if I go into my pods, I now have an error message here telling, you know what, there is an error here while pulling that particular image. Now there's no image existing, and it wasn't able to really create a pod for you. Reason being, there was no image. If there's no image, it won't be able to pull that particular image, won't be able to create it out. Since it is not creating a pod, Kubernetes is telling, okay, fine, wait, I'm not able to create a pod. I won't destroy the older one. Let me keep the older one the way it is. Let me run this out so that your application is not hampered at all. Your application will keep running. Your application will not be hampered at all. I'll wait until the, let's say, new pod receives this particular image. If it doesn't, I'll keep it the way it is, and I won't terminate this particular pod at all, or I won't terminate rather this one. Now I have an option to do a rollback once again. I can say rollout undo. I can simply say, okay, fine, you know what I want to roll back because this image doesn't exist. If I just refresh this out, this is how it is now rolled back. It's telling, okay, fine, you know what, these are all the old pods. I don't want to really touch them. The new pod is this one, or the existing pod which is actually working. Let me pull it back. Let me make it available for you out here as such. And it did not even hamper, or it rather did not really hamper the way the application is running. The way the application is running will always be intact without you having to go, or you having to go through all these things. The way the application is running actually is intact, and this won't affect your application. And that's the reason we call deployments, or we rather tell that the deployments are the best strategy for Kubernetes to go forward. The reason being, deployments are better than replica set. When you create a deployment, it will create a replica set. It will also create a pods inside replica set, manage all these things out. It will also make sure that the rollbacks and updates are achieved with zero downtime in a safer way. That is what I wanted to really tell on, or that's what I want to really explain on what Kubernetes deployments are, and what do I really mean by a safer way in order to go ahead and, let's say, achieve an update or rollback out here as such. And this is what in the next session that we're going to have on Monday, this is what we are going to try and achieve using an Azure DevOps deployment, meaning I have a file. How do I use Azure DevOps in order to deploy the same thing on a Kubernetes cluster is what we're trying to achieve. But this is what I want you to, I want you all to, take a look at on what really deployment definitions are out here as such. Yes, any questions I can take till you? Anyone, any questions that I can take on what is a deployment? Again, we just had a recap of what is a pod. I just said how a replica set is better than a pod. Finally, I'm coming down to deployment, and I'm telling there's nothing that you really need to, let's say, change in the YAML file. Just change the replica set to deployment, roll it out once again, and that's it. You're good. You can just go ahead, use something known as a deployment out here. And once you have a deployment in there, you can just go ahead, do a rollback, let's say, do a upgrade, rollbacks, and all these things in a safer way out here as such. Yes. Any questions, guys? Any questions till here? Anyone? Any questions that I can take till here? Any questions? Any confusions? Anything till here?
Uh, Abhishek,
Go ahead, Jayanti, please.
uh, I got this points, but the thing is, what is the difference between the DevOps engineer and DevOps software engineer? Because when I'm attending the interview,
Mm-hmm.
they
Mm-hmm.
clearly ask that what are you a DevOps engineering person or DevOps software engineering?
No, you will be a DevOps engineer. You're not a software engineer. You will be, let's say, something like a DevOps engineer out here as such.
What makes the difference between these two?
When I say a software engineer, right?
Hmm.
Yeah, I'll just put you on mute because I'm getting a little bit of echo. So when I say a software engineer, I'm thinking about you as both a DevOps out here and also someone who knows how to develop a software. Like you know how to write a programming language like .NET or Java and so on and so forth out here such. So they are expecting a dual role out there. In case, let's say, if the job profile is asking you something like that, so you should be a DevOps engineer, not a software engineer out here as such. That's the difference between a DevOps engineer and a software engineer out here, working also as a DevOps engineer as such.
So here, if I like, I know C plus language. If I C plus and Java, if I work, some example, if
Mhm,
my
mhm.
organization, maybe I'm moving into other path and I'm taking it like working on this particular project for the anything like programming on programming basis. So if I do this DevOps, Microsoft DevOps side also, so I can call it as a DevOps. Like I can try as a DevOps software engineering also. You
Yes,
mean to say?
yes, you can do that. Yes,
Okay, thanks.
no problem. Anyone, any more questions, guys? Anyone, any more questions that we
Hi,
can take?
hi, sir.
Go ahead, Kalyan.
Sir, my question is how many containers a pod can run, sir?
Uh, a pod can run, or are you telling how many containers a node can run? So if I understand your question, you asked me how many containers a pod can run. So inside a pod, you can have a number of containers. There is no limit on how many containers you can have inside a pod. But what we do for the health of the pod, or the, let's say, the safe running of a pod, is that we do one container per a pod. We say, okay, fine, I need one container per a pod in order to, let's say, avoid a lot of confusions out there. But if you ask me how many pods can run on a particular node, it depends upon the capacity of the node. As of now, Kubernetes kind of supports about 110 pods per a node out here as such. So if you ask how many containers are there inside a pod, I would say one. How many pods are there inside a node? I would say a maximum of 10. Oh, sorry, 110.
Okay, okay. And the meaning maximum of what the pods can run.
Sorry, maximum pods are 110 on a particular node.
Yes, yes, sir. Yes. Thank you.
Thank you. Anyone else getting any questions?
Uh, sir, is there any online offline classes is there at our institute?
As of now, no. I am planning something from, let's see. So next week also I'll be a little traveling here and there. So I will be available from the 26th. So from 26th, you can expect me to be offline out there. So I can take some offline sessions there if you have any questions.
Okay, sir. Okay. Thank
Yes, any more questions, guys? Okay, thanks, guys, and have a good day ahead. And we'll meet in the next session. Thank you.